Hello everyone, welcome to Math Tired Club, where we make the hardest thing look very easy. Don't forget to like, subscribe and comment and share this video with your friends if you find it helpful, and I think you do, so please do share this video with your friends. So today we're diving into limaçons, those beautiful heart-shaped and looped curves you've seen all over Pinterest and Instagram. I'll show you the easiest way to graph them step by step, and let's get started. So I'm gonna start with an example, and before I go to the examples, I'm gonna write limaçons here. Okay, this is what we're going to talk about. The basic formula for limaçons is R is equal to A plus minus B cosine theta, or R is equal to A plus minus B sine theta. That's the basic formula. There are some parts that you need to know in order to be able to understand what the figure is going to be. So the very first thing is this, that if A over B is less than 1, then we're going to have an inner loop. Okay, we're going to have an inner loop that looks like either this, or the other way around, you know, all if you flip it 180 degrees or 90 degrees, you're gonna get the loop. And if A over B, and I'm gonna choose red for this one, and you can imagine what it's going to be, is equal to 1, the one and only missing half of us, then we're gonna have a cardioid, or the shape of a heart. So it's going to be a cardioid, or the shape of a heart. Okay, so, and the next one is when A over B is between 1 to 2, in which you're going to get a dimple. I wish I had one. So dimple, you're gonna get a dimple. And the last one, so if A over B is greater or equal to 2, you're gonna have a convex that looks like a circle, and something quite more of a, not a complete straight line, but not the same curve as the other part of the circle, and we call it a convex. Okay, and something that I have to tell you, and you should have this in mind, is the fact that if you are graphing cosine is going to get reflected over the x-axis, and if you're graphing sine is getting reflected over the y-axis. Have this in mind. This is going to be really helpful in graphing. So I'm going to start with my first example. Y is equal to 2 minus 2 cosine theta. Okay, in order to graph this, the very first thing that you can do, and it's going to make everything 100,000 times easier, is the fact that if you just graph this, oh, sorry guys, this is R is equal to, because we're graphing it in a polar system. So if you want to graph this very easily, something that is going to be really helpful for you is the fact that if you graph this on a rectangular coordinate plane with an X and Y, everything is going to get much easier. So I'm going to write this in X and Y form. It's going to be this, and I'm going to be back with the coordinate plane. So ta-da, I'm back with the shape of the coordinate planes and the polar coordinate plane. So the thing that I want to emphasize on is the fact that you have to have this in mind, that the midline of this is going to be 2. So 1, 2, this is going to be the midline. So, and if cosine function looks like this, since this is getting reflected, then it's going to look actually like this. Okay, so if I want to graph this cosine on 0, it's going to be on its at its minimum point, which is going to be 0 over here, and on pi over 2, it's going to go back to 2. Okay, and then on pi, it's going to be at its maximum, which is this. Then it's going to come back to here and here. And then you plot the points and you graph this. Okay, so after here, we're going to go for graphing it. So the thing that we need to first find is the fact that what is the ratio of A over B. So A over B is going to be 2 over 2, which is 1. Okay, as you can imagine, we're going to have a cardioid, or the shape of a heart. So we're going to start on 0, and on 0, the cosine is 0. So look, on 0, the cosine is 0. So I'm going to go with 0. Then on pi over 2, which is over here, this is pi over 2. Cosine is on 2. So I'm going to have 2 on pi over 2. And as you can see, the cosine is kind of like increasing, going up. So I'm going to go the same way. And then from pi over 2 to pi, again, cosine is getting more and more, okay? And we're going to end up at 4 on pi. So this is going to be pi. This is pi over 2, 0, 3 pi over 2, and 2 pi, okay? So on pi, cosine is at 4, as you see. If you trace it back, you're going to see it's at 4. So on pi, it's going to be at its maximum 4. And as you see, it is increasing again. And again, at 3 pi over 2, it's going to be on 2. So it's going to go back to here. And you know that it's symmetrical. You can do the rest, but let's go together. On 2 pi, cosine is 0. So you're going to come back to this, and you're going to have the shape of a heart. Okay, so let's go for our next example. Look at this beautiful shaped heart. So our next example is going to be R is equal to 4 minus cosine theta. Okay, for this, the maximum of this is the midline is 4, of course, and the maximum is going to be 5. So first of all, I'm going to graph it. I'm going to go and come back with the coordinate planes. Ta-da! Here we are with the coordinate planes. So I'm going to write this in terms of a rectangular coordinate plane with x and y. So the midline is 4. So the midline is going to be 4. And so it's, if we want to graph cosine, if cosine looks like this, when it's getting multiplied by a minus, it's going to get reflected over the x-axis, and it's going to look like this. So for cosine over here, it's going to start at at 0. It's going to start from the least one, which is going to be 3, and on pi over 2, it's going to be 0, and on pi, it's going to go into its maximum. On 3 pi over 2, it's going to be on 0 again, and by 0 we mean the midline, because this midline is going to present this y-axis, and I have a video on this. You can watch it. I'll link it in the description box below. So, and on 2 pi, again, it's going back to its minimum, and the graph is going to look like this. After we graph this part is going to be really, really easy. First things first, let's find what is the ratio of A over B, which in this example is going to be 4 over 1, which is a number greater than 2, so we're going to have a convex. So on 0, we are at 3. So when x is 0, y is 3. So we're going to be at 1, 2, 3. On pi over 2, we're at 4. So on pi over 2, 1, 2, 3, 4. This is pi over 2. This is 0. Pi, 3 pi over 2 and 2 pi. On pi, we are at 5. So before I go on, see the graph is increasing here. So it's going to look like something like this. And then from pi over to 2 pi, again, it's going to be increasing, looking like this. More of a round shape, okay. Okay, and then from on 3 pi over 2, the graph is at 3. So the graph is gonna on 3 pi over 2, the graph is at 4, sorry. It's going to be here. See, 3 pi over 2, the graph is at 4. So it's going to look like this. I'm going to continue this. And then on 2 pi, the graph is at 3. And you could have just reflected this over the x-axis and it would have been the same. So like this. So we have a convex, as you see, and graphing these is actually super duper easy. So let's go and continue this. So ta-da, here I am with the coordinate planes. Now I'm going to have the example. R is equal to 1 minus 3 sine theta. So look, first I'm going to graph it in the rectangular coordinate plane. So it's going to be 1 minus 3 sine x. So the midline is going to be y is equal to 1. So, and if this is the graph of sine, if it's going to get reflected, it's going to look like this, okay? So we are going to go for this and let's use green. So on 0, sine is 0, which is going to be at the 0 that we have on the midline, which is at 1. On pi over 2, sine, it's going to be at its minimum, which is negative 2. On pi, again, it's going to be at 0. On 3 pi over 2, it's going to be on its maximum, which is 4. And on 2 pi, again, it's going to go on 0. And if I want to plot the points, it's going to look like this. Okay. Looks a little bit tilted, but then we're not going to use technology. We're just going to do it manually. That looks better. Okay, so does it? So let's go and start. Guys, if you can see these points over here, this means that we're going to have an inner loop. Without even going and finding the A over B ratio, we would know that we're going to have an inner loop. Look, if we find the ratio of A over B, it's going to be 1 over 3, which is between 1 and 2, and we're going to have a loop, okay? We're going to have either this or, I don't know, maybe this or the other way around. Let's see what's going to happen. So on 0, the sine is at 1. So on 0, the sine is at 1. This is 0, pi over 2, pi, 3 pi over 2, and 2 pi. So on 0, sine is at 1. But look, on this red point over here, the graph is going to go through the x-axis and the y is going to be 0. So it's like a fishing pole, and I'm just kind of like pulling it back. So I'm kind of pulling it back, and this number over here is not much more than 0. So it's before pi over 2, and it's not much more than 0. So it's going to go and come back. Maybe I'll make it more visible like this, okay? Come back to 0 because r is 0 there. And from this point, 0 to pi over 2, as you see, the graph is decreasing, and on pi over 2, the graph is going to be at -2, which is going to be on the other side. So it's like I'm going back to -2. So over here, let me redo this. And then there are two things you can do. You can just reflect this over the y-axis, because I told you that sine is going to get reflected over the y-axis, and you can just go with drawing this other part like this, or you can still kind of like calculate it. So from pi over 2, the graph is actually increasing, and before it reaches pi, it's kind of like going, see, the graph is increasing, it's going up, and it's going to the point where the r is going to be 0 again. And on pi, the graph is at 1. So I'm going to put the 1 on pi, but see what's going to happen. The graph is decreasing, the graph is going back, and before it gets to pi, it's gonna be on pi, it's gonna be on 2, and before it gets to pi, it's gonna be 0 over here as the other point that we had. And then on 3 pi over 2, the graph is at 4. So on 3 pi over 2, the graph is at its maximum, and it's at 4. And on 2 pi, the graph is going back to 1. You can do all of these with just reflecting it over the y-axis, and it's going to give you the same thing. So let's do the next example. So here I am back with our coordinate planes. So the example is going to be r is equal to 4 plus 3 sine theta. So it's sine theta, so the graph is going to just look like this. And the midline here is going to be 4. So I'm going to have 4 over here. So it's going to be 4, 5, 6, and 7. And 1, 2, 3. Okay, 1. So the graph is going to be at these points. So I'm going to have pi over 2, pi, 3 pi over 2, and 2 pi. So on 0, the graph is on 0. I mean the 0 that we have, which is the line y is equal to 4. And on pi over 2, it's at its maximum, which is 7. On pi, again, it's at 0. On 3 pi over 2, it's at minimum negative, which is at 1. And again, back on 0, I'm going to plot the points. Okay, this is going to be our graph. And after here, I'm going to go for graphing it on the polar coordinate plane. So on 0, this is going to be 0, pi over 2, pi, 3 pi over 2, and 2 pi. So on 0, my graph is at 4. 1, 2, 3, 4. That's going to be my graph. On pi over 2, it's at 7. On pi, it's at 4 again. 1, 2, 3, 4. So let's do it together. So as we go from pi over 2, from 0 to pi over 2, the graph is decreasing. So it's going to be looking like this. And as we go from pi over 2 to pi, the graph is decreasing. This one was increasing, this one was decreasing. And then I wish I could do it more like in a circle way. Let me do it again. So like this and like this. And on 3 pi over 2, the graph is at 1. So on 3 pi over 2, the graph is at 1. And oh, before that, I forgot to have a over b, which is going to be 4 over 3, which is a number more than 1. And we're going to have a dimple, okay? It's a number between 1 and 2. So if a over b is between 1 and 2, we're going to have a dimple, the thing that I wish I had. So we're going like this. And then let me change this a little bit. And then from this, we're coming back to this part. So as you see, it's kind of like a figure that looks like a dimple. So it's kind of like this part is just like going inside. It's like a fishing pole that we're taking it back inside. So guys, I hope that you have learned this lesson. I'm gonna add some homework into the description box. You can check that out. Please, if you have any problems with factoring this part, these parts that we did, there is a video that I have uploaded before. There are actually 2 videos. I use translation and transformation, and I also used just formulas to easily graph these type of graphs. You can use that. Please go and watch it. Don't forget to like, subscribe, and comment. I hope that you have enjoyed this video. See you in the next video. Don't forget to share it with your friends, and bye.